Hello everyone, welcome to the 5G Massive MIMO training. As you remember in the previous 5 session, we had covered very important information about what is Massive MIMO in general, for the first point here, and differences between passive and active antenna. Then we went through the beamforming in general differences or what is the meaning of beamforming. Then we went through a very important information about the beam management and downlink and uplink, and even much more important information details. I advise if you didn't watch those videos to go back and have a look into them because they are very important to gauge all the information announces about massive MIMO in general for the 5G. In today's video, actually, we are going to cover part number 6 or session number 6, which is will be about still under the beam management, but this will be covering mainly the beam mobility, including how the handover is being done or the beam mobility in general for the massive MIMO. Actually, the plan was to have the to lead today's video to the final session. I was planning to cover both beam mobility and beam failure in the same session, but I will split it into two different sessions. And also, I will add an extra session based on the many comments had been received. They are requesting to add a session related to the massive MIMO planning. So in general, we'll be ending by 8 sessions in Massive MIMO, where we have 5 already being shared in the channel, and now we are going to session number 6. Then we'll have additional 2 sessions about 5G Massive MIMO. There is multiple other good information not being shared. I have highlighted this already before. In case if you would like me to cover any of them, you can just drop a comment and messages in the YouTube channel, so I will be able to evaluate whether these sessions are important or not. So let's move forward. We have to see what we have about the detailed content of today's session. So again, today's video is going to be covering the part related to beam mobility management, where we'll be mainly speaking about the beam switch or beam switching for the intra-cell mobility and the other way around for inter-cell handover or inter-cell mobility. How both of them are working in 5G Massive MIMO, what kind of parameters we need to look into whenever we are trying to optimize or understand the behavior of the beam mobility in general or handover in general in Massive MIMO. And also, I will be adding an additional point related to the differences between SNR, different SNR in the 5G technology, because this was supposed to be part of the previous session, but I had dropped it. So I will be covering this part today as well. Also, I'll be sharing one important information about the CSI-RS SINR reporting capability, how to check from the UE capability messages, because sometimes you might do your optimization for the beam mobility based on CSI-RS SNR. So before doing this kind of information, you need to confirm like the insight about your network, how many devices supporting the reporting or the CSI-RS SNR reporting or not, because based on that, you will decide whether, for example, if all the devices supporting SNR for CSRS, so you will be able to design your network mobility or beam mobility management based on SNR as an example. So let's move now to cover the details about the beam mobility management in today's video. So as you can see in this slide, in general, the beam mobility management in 5G Massive MIMO, it's divided into 2 different categories, as you can see in the figure in the bottom left here, or in the summary in the top right, or in the right side of the slide. As you can see, first of all, you should know, based on this comment, the base station and UE must be capable of changing beams as the radio condition change. So whenever there is a radio condition being changing over time, for example, the UE or the device, the user is moving from one location to another at different timing and so on. So the UE will have a different radio condition. So the base station and UE should be capable of adapting for this radio condition change through adapting or changing the serving beam, right? So as you can see in the bottom left figure here, there are 2 different categories of beam mobility management in 5G. The first one is called intra-cell handover, which is beam switching, like whenever you change from one beam to another, but within the same sector. For example, here you're assuming you have 3 sectors, sector one, number one, and this sector number one is served by different number of beams. for example, 8 beams or whatever, 8 SSB beams as an example, and you have sector number 2 with the same, then sector number 3. So, for example, assume now the user is moving from one beam to another, this third and fourth, and so on. So the G node B should change the serving beam from the user to ensure that the user is being served by the best beam which have the best radio condition, which can guarantee that the user is served by the best beam to have the best coverage and so on, right? So usually this one is called, as you can see in the figure on the right here, it's called intra-cell mobility, which is just doing a beam switching, like changing from one beam to another, beam 1, beam 2, and beam 3. And this is usually done through the within the L1 and L2 procedures, which is the physical, and MacLear is handling this completely, which means that the beam changing, the unit beam might change the beam to the UE, and the UE at this particular case will be transparent and seamless. Like he will not understand, or you will not know that the gene will be already changed the beam. Like this is, as you mentioned in this comment here, the beam level are transparent and seamless from the UE perspective. Okay, and this can be done based on two different categories, or multiple categories or multiple inputs. For example, whenever the UE can report based on periodic CSI reports, for example, something called CRI or SSB RI reporting, which is, if you remember from previous session, CRI refers to CSI-RS resource indicator, and this is SSB resource indicator reporting, where the user is reporting through L1 and L2 the coverage of the served CSI-RS beam or SSB beam, and telling him what is my coverage, what is the beam ID or beam index, so the unit B will know how to change the weight of the beam and start targeting a new, for example, traffic beam and so on. The second one, this will be covered in a complete different session, because this require like kind of more details which related to the enhanced TCI. This will be covered in different video. This is the first time of the beam mobility, which is called intra-cell mobility. I will be covering this in more details in the next slide as well, just to give you an overview about from draft test what you can see, and also what kind of parameters you might need to look into for both intra-cell and even intra-cell mobility. The inter-cell mobility, actually, which is the second type, as mentioned in right figure here in the bottom right. This is whenever you change from one cell to another, even within the same site or for different sites. So you are doing a handover from, for example, cell 1 or sector 1 to sector 2 within the same site, or from sector 1, assuming there is another site outside here. So you're moving to another site to another site within different cell, right? So this is inter-cell mobility. Okay, it can be inter-cell intra GMB or inter-cell intra GMB, right? Handover, and this is typically is very like similar to whatever we used to have in general in the handover procedures, especially, for example, comparing to 4G, which was mainly relying on different events. E3, for example, which is was typically used for intra-frequency handover, and some particular cases you can configure it even for inter-frequency handover, and you have the A5, which is used typically for interfrequency handover. And this is mainly done through the RRC messages, which is called L3 procedures. This is require kind of RRC signaling involvement here. So it requires reporting from the UE to GMB, and the opposite way around. GMB need to deliver particular configuration and also need to inform the UE about the new target cell. While again, the main difference is to the intra-cell mobility, that this one is transparent to the UE, which is the intra-cell mobility with beam switching, where the GMB does not require to deliver any information to tell the UE about the new beam. Okay, this is just the main difference between both of them. In next slides, we'll be covering both of them with more details, more visualization, and also will include some of the parameters and optimization which is being done for different networks, just to give you a complete overview about the beam mobility procedures in the 5G Massive MIMO. So now let's continue with more details about different beam mobility in 5G Massive MIMO. So again, the first type where I'm going to cover, it's about the intra-cell mobility beam switching. As you can see, this is intra-cell mobility beam switching. And as I highlighted, intra-cell beam mobility switching can be both transparent and seamless from the UE perspective, where actually the UE can be instructed by the GNB, can be set to generate periodic CSI reports with report quantity for example, CSI-RSRP, which is integrating for CRI-RSRP, this one, which is again a CSI reference signal resource indicator, or other something called SSBRI, which is integrating SSB block resource indicator. What it means by this, it means that the GMB will be delivering within RRC reconfiguration message the report quantity, telling the UE I will require you to report either the CRI or SSB RI to be able to judge which beam you are going to serve from. For example, let's assume the user is moving from one SSB beam to another in connected mode, or from one CSI-RS beam to another CSI-RS beam also in connected mode. So the GMB will know based on the reporting information which beam is going to be served for this particular UE. So these indicators, which is highlighted here, will be provided by the base station, and based on that, the GMB can use this information to switch between beams without informing the UE. And actually, can be done by changing the set of beamforming weights which are applied to the resource blocks allocated to either the PDCCH or PDSCH. I will explain this one now with more visualization and so on. So we can summarize it into few steps. So let's now try to visualize and see what we have. So the first step, GMB will be delivering the bottom right message here in RSC configuration message, telling him, for example, I would like the U report quantity for the beam switching or intra-cell modality beam switching to be big. For example, I would like you to report both even SSB or RI or CRI. So, for example, in this case, was telling him, I would like you to report SSB index RSRP. But in the case you are highlighting here, the user will be changing from one CSRI beam to another CSRI beam. So the user will require to report this CRI. So initially, in this figure, the user was being served, reported initially that I would like to camp in CRI1, which is CSRS1, beam 1. So GNB in this case will start calculating the beam weighting, would do the beam weight calculation, and it will assign the particular resource blocks and the particular beam towards the user, which is PDSCH beam and traffic beam and so on. So the GMB, based on this information, will know that, for example, this beam is associated with a specific PDSCH beam and so on. Then after a while, the user changed his location. He moved, for example, towards another beam direction. Let's say another this CSRS beam within the same cell, which is again intra-cell mobility handover. So what will happen? The user in this case will do again another CSI reporting. Will report the new CRI, which should be equivalent to CRI number 3, as you can see here. So in this case, again, the GMB will start doing the new calculation to start. This can be associated, by the way, with another information like PMI and so on, as we discussed before in previous session. But in this case, GMB will start doing the beam calculation, and it will start allocating the new traffic beams based on the reported information. And all of this, the beam changing for the traffic beams, will be seamless and transparent to the UE. The GMB doesn't require to send, for example, any RRC message or anything else to let the UE know which one is being changed or which traffic beam is going to be used. So now, based on this information, the GMB will do the calculation of the beam weight calculation and will assign the new resource blocks and new beam of the traffic PDSCH beam and so on. And again, all of this is happening through the L1 and in the L1 and L2 procedures, and it doesn't require any involvement of RRC signaling, except in the very beginning whenever the GMB is delivering the report quantity and the other information to the UE. Actually, the base station the basic beam switching scenario in general can be enhanced using something called TCI, or a set of transmission configuration indicator. This is TCI stands for transmission configuration indicator. So the beams beam switching scenario can be enhanced using a set of transmission configuration indicator, TCI states, to specify something called quasi-collocation or QCL relation between the PDCCH and reference signals, and also between the PDSCH and downlink reference signals. Again, I will be covering this one in complete different session because it requires additional information. But just to let you know, 3GPP introduced the concept of a QCL relation, which is this one, to help the UE with its channel estimation. I will be explaining this one in more details, but just in information, additional information sent to the UE to help him with its channel estimation, frequency offset estimation, and also other reference signal and so on. This one will be covered in more details in next session, but let's try to get an example from drive test logs now. Whenever the user, for example, change the SSB beam, how this beam happening, what kind of information is going to be reported from the UE to GMB, and how GMB will be changing the beam and so on. So let's move to the next slide as an additional practical information for the intra-cell mobility beam switching. So this example is mainly covering a scenario from the drive test perspective. This is about whenever you have changing, for example, your serving SSB beam, the GMB, for example, changing from one SSB beam to another SSB beam. So, for example, just to quickly recap, in general, the number of SSB beams which can be transmitted to the user. This is depend on the vendor implementation, but in general, 3GPP defined for frequency range 1 maximum as 8 SSB beams can be transmitted. So this you can confirm from your network based on for a standalone based on system information block type 1. You'll find something called, if you zoom in here, you'll find something called here SSB position, and under this one you'll find something called N1 group. If all it having 8 bits, as you can see, if all of them is 1, this means you have active 8 SSB beams. In case if they are 4, this means they are 4. In case if they are only 1 and the remaining are 0, this means you have only 1. So here I'm assuming you have 8 SSB beams, and again the GMB will be delivering some information to let the user to instruct the user to report the coverage and RSRP through the L1, L2 message, and the beam index as well, which is SSBRI, to tell them to let the GMB to the UE to report this information to the GMB. So this is how the information will be reported. As you can see in this example in the middle here, the UE will report the SSB beam index, which is SSB beam index, which is BRI, with the strongest RSRP through L1 and L2 messages. So here is just this is from the draft test logs. GMB will being able to see this kind of information, which is including SSB beam index, for example 0 to 1 and 6, and each of these index representing a different beam in the cell. So here each beam you'll see that it's having a different coverage. So based on that, the GMB will know which one is the best. For example, in this particular example, the best beam was beam number 0, which have a coverage of 91 dB, while the other is kind of far away. Only SSB beam 6 was nearby, but this is the best one. So in this case, but it have different RS antenna, so you can average all of them to see which one is the best. But at the very end, we are assuming here SSB beam index is 0. So, but whenever the user is moving to another beams, the GMB will decide which one is going to be used as a transmission point of view for this particular view. So it will understand also where the user are located. So for example, here just from drive test, each color representing again a beam index. So we'll find whenever the user is moving, the beam will be changing. For example, here different color, green, red, and so on. So this is how the GMB will switch this is beam based on the reported L1 RSRP and SRBI, SSBRI from the UE. This is a type here. This was all about the inter-cell mobility handover. Now let's move to the inter-cell mobility handover, which is typically used in all networks. So and it have a very good and important information. Let's move forward to see what we have. This part is covering the part related to the inter-cell handover mobility, which is mainly based, as I mentioned before, based on event A3 or event A5. So again, this scenario, as I highlighted at the very beginning of today's video, that whenever the user is moving from one, for example, site to another, from one cell to another cell, which is mean inter-cell handover from one sector to another sector. So this required to rely on A3 and A5 events to trigger the handover. And when you are saying A3 and A5 events, this means the user RRC signaling now is being involved. So this means the JNB required to deliver the related event to the user to let him what kind of average RSRP is required to send the measurement report. So based on the measurement report, the GMB will decide which shell is the best cells. But there are two very important pieces of information I would like to let you know. First of all, the inter-cell handover mobility is more about the cell level measurement, not beam level measurement. For example, assuming that the user is moving from this side to another side, from one sector to another sector. So the user need to know what is the cell level coverage, RSRP, not the, for example, beam level. He already know the information of beam level, but he need to calculate out of the beams, different beams, the cell level handover to, for example, decide which one is the best one. For example, assume you are moving from this side to another two sides, which one is here, and assume one in the bottom down here, and both of them had different recondition. So the question is how the user will be calculating the cell level measurement for those for these two different sites. For example, assuming here we have 8 beams and the other one having 8 beams as well. So this involving something called cell level measurement, and this is actually will let you. This is kind of parameters will be delivered to the user to instruct the user how to do the cell level measurement to decide which cell is the best cell to be sent in the measurement report from the UE to the serving GMB, which will decide which cell it will going to do the handover towards the target cell. So how this being done? So initially there are two parameters going to be delivered. One called AVS threshold SSB blocks consolidation, and the other one called number of SSB blocks to average. And those two parameters can be used during the cell level measurement and the cell reselection. So the user can decide which cell is the best during the cell selection or during the handover. So in case of cell selection, this information will be delivered within system information block type 2 or system information block type 4. In terms of handover, which is our topic today, it will be delivered through dedicated signaling, which is RRC reconfiguration message, to which will allow the user to do the measurement reporting and to allow the user to do the handover through calculating the cell level measurement. So the question is how these parameters are working and how the user will using these two parameters to decide which one, how to calculate the cell level measurement to decide which one is the best cell. So initially, this you have two parameters. The first one in the bottom left here, and the bottom down here, a scale number of SSB blocks to average. This is like tell him how many blocks or SSB you are going to do the average. Assume you have 8 SSB beam within the cell, right? So if this parameter is set to 2 or 3, this means the user need to do average for 2 or 3 beams or SSB beams. But which beams of the 8 he would require to do? It should be the best one, right? So how the best beams will be decided based on the SSB blocks, based on the other parameter, which is called AVS threshold SSB blocks. So for example, this is a threshold telling him that it's 100 dB. So any of the SSB beams will be better on those SSB beams, will be a candidate for the averaging to decide the linear average to decide the cell level measurement. So assume this one, you have 3 beams better than this threshold, and your other parameter, which is called the SSB blocks to average, equal 3. This means what the user will do in this case. In this case, the cell level measurement is defined as a linear average of the strongest measurement result, which exceed the threshold defined by this particular parameter, which is called EDA threshold SSB blocks. This means this will have a linear average of the 3 beams, so the user will be able to send down the measurement report to the GMB. But what if the user was not being configured of any of these two parameters, okay, as a cell level measurement information, or none of the beam, for example, or none of the beam level measurement, one of these beams exceed this particular threshold, as the second example. So first of all, maybe these parameters will not be delivered at all to the user, or maybe the beams will not even, any of the beams will be achieving the threshold, as this example. So in this example, what will happen? Just the strongest beam will be selected, and this will be considered as a cell level measurement, and this will be considered in the measurement report, which is going to be sent from the UE towards the GMB. So this was the first important piece of information, that how the UE will decide the best neighbor cell for the whatever targets he have. Let's assume he have 3 or 4 sites. So this is he need to perform this cell level measurement through the mentioned parameters here. The second part and second important information. Assume now the GMB, the UE, is going to be handed over to another one, right? And he already decided that this site or this cell is the best cell based on measurement report. So the measurement report, it should include another important information to let the serving GMB or the user himself understand, to tell the GMB which one with which beam within the beams are the best beam, right? So assume now you have uh, you have 8 beams, right? And the user already decide which one is the best cell based on whatever you have just discussed here. Now there is another important information the user need to know, or the GMB and the user need to know. For example, uh, the handover is going during the execution phase is going to done based on contention free or non or contention based, which means based on dedicated preamble or non-dedicated preamble. And this is another story, that whenever you have additional parameter called RSRP threshold SSB, and this parameter usually delivered delivered in the RATCH configuration common parameters, and the user using this to decide whether he's going to send something called contention. The GMB and user decide based on this parameter whether the handover will be during the execution phase will be done as a contention free or contention based. How this can be done, and how the user will know based on this parameter that he can now initiate a contention free. As you know that usually the contention free require initially some a dedicated preamble to be assigned to the user. So the user will be using this preamble to send it to the GMB to avoid any collision, right? But this is not really, it's the case, but not the exact case, because as you remember in the session number 3, as I remember, we have highlighted one important information. Let me bring the picture of this information to let you understand more about what I want to say here. Just to quickly recap as well, as mentioned, this command usually handover typically try to take advantage of the contention free random access, right, to improve the reliability and also improve the reduce the latency, because the usually the contention base required that might be a lot of collision. The user will be sending through a random preamble, so this is might cause a collision with a different users and so on. So actually what will happen in this case, this is required the target cell to allocate one or more dedicated PDSCH preamble, which I'll link it to this comment. What it means by this comment, if you remember, I have highlighted before that during the execution phase, so there will be an information being delivered to the user telling him that each of the SSB beams within the site, for example, is associated with a specific preamble. For example, SSB beam 0 is associated with PDSCH 0, 1, and 2. So the user can use this one for the contention free. But when the user can decide and the GMB can decide whether the user is going to use contention free or non or contention based in this case, right? This is a question. This is actually based on this particular parameter, which is called RSRP threshold SSB. This will be delivered to the user as well. If any of the beams are better than SSB beams, better than threshold, for example, assume this one neg 100 and you have a beam which is neg 99 and the rest are worse than neg 100. So in this case, for example, SSB beam 1 is being to be used, and SSB beam 1, for example, in this case was associated with PDSCH 3, 4, and 5. So the user will be initiating the handover execution PDSCH using this PDSCH preamble, which is associated here. And in case if the threshold are not met, so this means this would be using contention base. So this means the user will be sending a random preamble to using during the random access during the execution phase. So this will be using a contention base using a random preamble in case if this parameter is being set. So this is actually the meaning of the second parameter, which is mainly used to decide whether contention free or contention based are going to be used, and which beam are the best beam is going to be selected on top of the cell level measurement. So the measurement report at the very end, which is going to send by the user, it will contain a cell level measurement, the average of the cell level, and also it will contain the reported best SSB beams within the same measurement report. This is the case where we have it here. Another just a side information, the bottom left comment here. If you zoom in here, sometimes you might need to design your mobility, for example, based on not SSB beams or SSB RSRP or SNR or SRQ. It can also, in some particular cases, based on CSI SINR. However, I didn't do this or use this part before, but just to let you know that cannot be done unless you confirm that the users in your network are supporting the CSI SNR reporting. How you can confirm the capability? This is an optional UE capability, which UE must declare separately for frequency range 1 and 2 through using this CSI SNR measurement flag. This is in the UE configuration, UE capability message, and you'll find this flag. For example, if it's flagged as 1, this means it's supporting this CSI-SNR measurement, and it will fund it under something called measurement and mobility parameters FRX differentiation. This is actually a side information here. The next and last slide of today's video, it will be about the differences between SINR and what kind of SINR we have in 5G and what is the main differences between all of them. And there's just additional information which I missed to cover in the previous 5 session. Just quickly before moving to the next session, I would like to show you like one particular example when we did the tuning in one of the networks. For example, I highlighted this RSRP threshold SSB, right? Which is SSB, which is what deciding here whether contention free or non-contention based, contention based or contention free is going to be used during the handover execution phase or during the handover in general, right? So this parameter, for example, here is the values where you have it, 3GPP values. So for example, here we tuned it, we would reduce the value. For example, let's assume it was 120, we make it 110. So we reduce the probability of getting, for example, contention-free random access, because now it's more difficult. You need the beams to be better than 110 instead of 120 to initiate the user, so the user will be able to initiate contention-free random access procedures. So for example, in this case, we tuned the parameter, we found reduction in the contention-free attempt, and at the same time improving the success rate. And was also the opposite way around in the contention base, where we have seen increase in the attempt, but also there was an improvement in the right success rate. So we get to know, for example, that the parameter value where we choose was the best optimal or the optimum value for this particular network. This was just an example for the this particular parameter, which I highlighted that each SSB beam corresponds to a unique preamble index, which can be used for the contention-free random access procedures. Now let's move to the last part. Okay, this actually slide, as you can see here, I'm highlighting the different types of SINR in the 5G. We have mainly three different types, which is each is serving a different purpose as highlighted here. The first one, which is related to the SS block SINR or SS synchronization signal SINR, which is actually mainly used for coverage and mobility evaluation, as you know, right? The second type, which is related to CSI-RS, SINR as well, or RSRP, which is mainly used to estimate the estimated based on CSR. For example, the CQI and your CQI and even beam switching estimation can be done based on the CSRS reporting in general, even RSRP and SNR. And also it can serve as an input for link budget calculation. But again, as highlighted in the previous slide, that in general, CSRS SNR reporting require a specific UE capabilities. And I already highlighted how to check this one. The last type actually is related to the PDSCH or the shared channel, PDSCH SNR, which is called effective SNR. And this is actually can be used along with the CQI, with the CSRS measurement to evaluate or to do the CQI estimation. So in general, like this is depend on the UE implementation. Some of the UE mainly do the CQI estimation, the CQI reporting from the UE to GMB and the CSI report based on the CSRS. But other UE implementation can do it both and both, actually, based on the CSRS plus the PDSCH SNR. And this might result in even much better CQI reporting. Why? Because, as I will highlight, usually the PDSCH SNR is better than CSRS SNR, is better than the SS SNR. Why? Because first of all, the reporting for PDSCH SNR is every, for example, let's say TTI, right? Which is typically 0.5 millisecond or 1 millisecond, depend where you're reading 30 kilohertz or 15 kilohertz. Also, the interference might be much less compared to the others. But also the main important information that because it's reporting every TTI, so this is given more accuracy compared to the others. And why the CSI-RS SNR is better than SSB block SNR? As you know that the CSRS is like on-demand reporting, right? It's dedicated, like each user can have it. It's not something there all the time. While the SSP block, it's transmitted all the time, and both of them are periodic. But just the CSI-RS in general is being transmitted whenever the user is in a connected mode, whenever the user is start doing a download and so on. So the probability to have a collision is much less. And also each PCI or physical PCI will have a different location, as you can see here. So the probability to have interference is less compared to the SSP block, which is being fixed in the same location, as you can see here. Again, for the SSP block can be different in different network implementation, but based on 3GPP, this is the scenario we have. SSB block is fixed for all the location is fixed, so this can cause additional interference. Plus, it's also transmitted all the time. And all the time based on the periodic reporting 20 milliseconds and so on. But yeah, this is the main difference between all of them. And this is how requirement and different purposes for the different SNR we have in the 5G. While in the 4G, if you remember, it was mainly based on the reference signal measurement. So we used to have only one SNR information in the 5G. And that's all about today's video. Again, I hope if you like the video to press like and to share the information and to spread the knowledge. And thank you very much and see you in the next video.